All right, gang, chapter four. Well, actually, lesson number two, basic probability, part one. I had a PowerPoint here and I was going to squeeze it all into one video, but I decided to put it into two videos. So this is going to get pretty in depth. So, I highly recommend that you kind of find a quiet place, take exceptionally good notes on this part because there's going to be a lot of information that's going to be thrown at you. So, let's get into it. First of all, what I'm going to try to teach you in the next two instructional videos are just more on basic probability concepts, and then we're going to get into a little bit on conditional probability. And again, this gets more in depth. It's pretty heavy on the notation, um, and I think it's probably some of the more difficult material that we study the entire term. So just to, again, I don't want to build a house on sand. Let's talk about some things that we've discussed previously. A sample space is just a collection of all possible outcomes. So if we have a fair die, then we could get any outcome from 1 to 6. And if we're dealing with a standard deck of cards, we know that we have 52 cards, aces, kings, queens, spades, clubs, and so on and so forth. A simple event is something that is described by a simple characteristic. A joint event has two or more characteristics. So if we're just looking at, randomly selecting a day in January from 2019, we're only doing one thing, selecting a day in January. But if we add into that the day in January is also a Wednesday, then we're adding in another characteristic, which moves us into being a joint event. And as we talked about in a previous video, a complement of an event A is just that it did not happen. So if our event is all the days in January, then complement would be all the days from 2019 that are not in January. Uh, Probability will always be have a value between 0 and 1. If you calculate a probability that's above 1 or is negative, then you've made a mistake. An impossible event has a probability of 0. An event that occurs every single time uh, is equal to 1. For example, if I roll a fair die, which we just saw on a previous screen, the outcome has to be either 1, 2, 3, 4, 5, or 6. Well, if I roll a die, what's the probability that the numerical value is 7? Well, it can't happen, so the probability is 0. If I roll a single die, what's the probability that the face value is either a 1, 2, 3, 4, 5, or 6? Well, that's going to happen every single time, so that probability would be equal to 1. Mutually exclusive events. These are events that cannot occur simultaneously. So let's say the event A is a day in January. The event B is a day in February. So we randomly selected a day in January and a day in February. Well, those two outcomes are mutually exclusive because what we choose at random can't fall in both A and B. So that's what we mean by mutually exclusive, is that the events cannot occur simultaneously. Collectively exhaustive events just means that one of the events must occur, and then the set of events covers the entire sample space. So if we randomly choose a day from 2019, and let's say that we have events A is a weekend, or I'm sorry, A is a weekday, B is a weekend, C is January, and D is spring, then the events A, B, C, and D are collectively exhaustive, but not mutually exhaustive because a weekday can be in January or spring. But we can say that events A and B are collectively exhaustive and mutually exhaustive because a day cannot be in a weekend and a weekday. So that's just one of those things you have to get in your notes. And when you run into collectively exhaustive and mutually exhaustive in your homework assignment, refer back to the definition. Again, I like to think of things as mutually exclusive. Just means that it can't happen in both events. Now, different approaches to assessing a probability of an event. We've already talked about priori, empirical, and subjective probability. In fact, in the previous video, when I demonstrated how to find the mean, the variance, and the standard deviation of a discrete probability distribution using StatCrunch, we had an empirical probability there. And if you notice that we calculated the probability in just the number of ways that the event could occur over the total number of possible events. I forget the number of, I think there were, what, 128 total. And remember, to find the probability of 0, I just took the count of 0 divided by 128. Now, the probability of a priori, which is based on prior knowledge, an example of that would be a deck of cards, right? I know what a deck of cards consists of because of prior knowledge. So the probability is just the number of ways that an event can occur over the total number of possible outcomes. For example, let's say my event is randomly selecting a card and it being an ace. Well, the number of ways that can happen are 4 because there are 4 aces in the deck. The total number of ways that I can pull a card from a deck of cards is 52, so the probability would be 4 out of 52. And then the subjective probabilities we've talked about previously is a combination of past experience and personal opinion. I feel like I covered that adequately in the first video. Now, so an example of priori, as we talked about before, would be this. The empirical probability, transitioning from a probability distribution, as I demonstrated on StatCrunch in a previous video, into a 2x2. So let's take a look at this, because this is a little more difficult and a little more challenging than the probability distribution. So find the probability of selecting a male taking statistics from the described table. So it looks like what we have is gender, and they have coded this dichotomously as male and female, and whether or not the student is taking stats. So they either are or they are not. So find the probability of selecting a male taking statistics. It looks like we have 84 who are taking stats and male. So we would take 84 over the total of 439. So we would have a probability of 0.191. Again, we talked about subjective probability differing from person to person. And again, I kind of like the second red bullet. The chief media officer of a company is less optimistic and assigns a chance of 40% to the campaign, where another person assigned a 60%. So it's completely subjective based on a person's prior experiences. Now, let's move into contingency tables, and this is where things get a little crazy. And so the example I want to look at is one variable, let's just call it event A, is whether or not a person plans to purchase a TV. I think we've all gone into Best Buy and maybe Walmart, wherever, and looked at the TVs on the wall, right? And maybe we walked in there with the plan to purchase. So we either plan to purchase, yes or no. Now, we walk out the door. Did we actually purchase? Well, either we did or we didn't. So that's another event. So if we combine the two events, plan to purchase with actually purchased, we get this 2x2 table. Now, first of all, we can see that 200 people planned to purchase, and they did. We have 50 people who planned to purchase, but they did not. So that gives us 250 people total who actually planned to purchase a TV. Of the people who did not intend to purchase a TV, 100 actually, they must have a very good salesperson. because 100 actually purchased a TV, even though they walked in not planning to buy a TV. And then 650 had no intent to purchase a TV, and they did not purchase a TV. Now, if we look at the columns, actually purchased a TV, we can see that 300 did, 700 didn't, and we see we have a total sample size of 1,000. Now, we can get into all kinds of crazy, and we will, different types of probability calculations using a 2-by-2 table. So before we move on, let's get into a little bit of notation. If we have A, and it looks like a gigantic U, that's just the set notation for union. So that's read A union B or A or B. So it's thought of, does event A or B happen? Now the opposite of that is A intersect B. That's the upside down U. And that's a typo. That should not say, where I'm circling, that should not say A or B. I copy pasted and not well. That should say A and B, and it's corrected out here. So A intersect B tells us that both A and B had to occur. So it's going to be important moving forward in calculating probabilities for these 2-by-2 tables. All right, I'm going to end the video here, and we'll take up with this in the next video. Take care.